Hey, developers! Welcome back to our channel. Today, we're delving into another powerful design pattern in Java, the facade design pattern. If you've ever found yourself juggling multiple subsystems and wishing for a simplified interface, the facade pattern is here to rescue you. Stick around as we explore its definition, advantages, pitfalls, and, of course, a hands-on example. The facade design pattern is a structural pattern that provides a simplified interface to a set of interfaces in a subsystem. It acts as a unified interface to a set of interfaces in a subsystem, making it easier to use and reducing dependencies between your code and the subsystem. Imagine you're dealing with a complex system with multiple components, and you just want a straightforward way to interact with it. That's where the facade pattern comes in handy, providing a unified interface to a group of interfaces in a subsystem. This separation of concerns allows clients to interact with a simplified interface, while the underlying subsystem components can evolve independently. Let's jump into some code. I have a Java project set up, and will implement the facade pattern to simplify interactions with a complex subsystem. We'll create a facade that provides a unified interface, and we'll use it to interact with multiple subsystem components. I'll guide you through each step of the code, and by the end, you'll have a solid understanding of how to use the facade pattern in your projects. The DVD player, audio system, and projector classes represent subsystem components. The home theater facade class provides a simplified interface for common actions like watching a movie and ending the movie. It interacts with the subsystem components on behalf of the client. When the client interacts with the home theater facade, it doesn't need to know the details of how the subsystem components work. The facade encapsulates the complexity, providing a cleaner and simpler interface for the client. Now, let's talk about the advantages of using the facade pattern. 1. Simplified interface. Clients interact with a simple interface, abstracting away the complexity of the subsystem. 2. Reduced dependencies. Clients are not exposed to the details of the subsystem, reducing dependencies and improving maintainability. 3. Easier to use. Facades make it easier for clients to use the system by providing a high-level interface. However, let's be aware of potential pitfalls. 1. Limited flexibility. The simplified interface might not cover all use cases, limiting the flexibility for advanced users. 2. Increased maintenance. If the subsystem changes frequently, keeping the facade in sync might require additional maintenance efforts. And there you have it, the facade design pattern in Java. We've covered its definition, advantages, pitfalls, and even implemented it in a coding example. Whether you're dealing with a large codebase or just want to simplify interactions with a subsystem, the facade pattern is a powerful tool. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more coding insights. Happy coding, and I'll catch you in the next one.